So hey guys, we are going to discuss problem 1302, which is deepest leaf sum. So let me just read out the problem statement pretty quick from the lead code website. So basically what we have given a root of a binary tree and we have to return the sum of all the leaf nodes of that binary tree. Not all the leaf node, but at the leaf nodes that are at the deepest level. If we look closely, like there are three leaf nodes. So first let me tell what is a leaf node. Leaf node is a node basically uh, which doesn't have any child. So it means its left is null and right is null. And deepest means the node which is at the deepest level or the last level. Like if we look, if we consider this as a zeroth level and this is the third, so this will be the third level, which will be the last level, and these nodes are leaf nodes, and sum of the deepest leaf node of this tree will be 7 plus 8, which will be 50. If you look closely, this is also a leaf node, but it is not at the deepest level, it is at the second level. So basically we won't add its value, 5 in our answer. So it will be 15 only. So the thing is how to approach the problem. It's pretty simple. Uh, First, let me tell you the more easy way. Like if you think about leaf node, or like if you have to sum of values at any level, simply what you will do. So you use a BFS approach. Pretty simple. Like if you want to sum of the node at any level, you can pop it in a queue and add those values. Like create an array for that, a temporary array, which will be size of queue. If you can't understand like why we are doing this, so you can watch other videos of mine like zigzag traversal and the other videos. So just think like we have to sum node at a level, like all the deepest node will be at a single level na? Even if like this is 9, so this is fourth level, so we will sum nodes at the fourth level, even if there is one, but we will sum all the values or all the nodes. Like if there was 10, so we'll sum 10 plus 9. And to do that, you have to go in a level wise order or level wise manner. So to do that, we need a queue. In a queue, you'll push the root node, and for that size of the queue, you'll create a temporary array. Okay, and you'll create an answer variable, or you can say anything, sum. You can name it anything. I'll name it sum, which will be self-explanatory. Sum, it will be as 0, and we will update the sum for each value in temp. Let me just explain. First, we put the root in the queue. Then for the size of that queue, we'll create a temporary array and push the node's value in the temporary array. Like we'll push, or you can say like we pushed 1, and like we pop 1 from here and we'll push its child 2 3. So currently the sum will change to the sum in the temp. So or rather than using temp, yeah, rather than using a temp variable, I don't think we need basically. So sum will be 1, and like if we popped it out, if we pushed new nodes, sum we will initialize again with 0. So if we put its child, so we know there are two elements. Wait a second. We know there are two elements, so we'll sum these values, which will be equals to 5. And like if we pop 2, or let me just write it again, sum was 0, then you pop 2, you add 2, and you'll push its child, which is 4 and 5. Then you'll pop 3, you'll add in the sum, you'll add its child 6, and then what you'll do, like when you are again iterating, when you are like your size, when you like if earlier your q was this much, you are only having 2 and 3. So first your pointer will be here, then your pointer will come here. Like as soon your pointer reaches at the last index, and when you have to move to the like reaches the last index basically, so some value will reset. Okay, so again it will be turned to 0. So that's how you can save the value of the last nodes basically. So then your pointer will be here, size is 3, you know, as you can see. Then you'll iterate, you'll add these values 4, 5, 6, and for 4 we will pop 4, you'll put its child 7. For 5 there is no child, you won't do anything, you just add it here. For 6 you will remove 6, add its child and sum it up. Basically then again your sum will again initialize to 0. Then you will pop this value, there is no child, you won't add any value, and add 7, and then you'll add 8 also, which will be 15, and you will simply at last, like when you know your queue became empty, so you'll return the answer. So if you think what was the approach, like we always know the values at the last that we will be having will always will be the values of the last level, and we just basically want to do the sum of those last values. So that's what we did. If you couldn't understand, you can rewind, or I am explaining a much better approach which is more intuitive, I'll say. So if you again look at the question, basically you have to find the same deepest leaves. How, like there's a this leaf 7, there's this 5 and 8. How you will consider this leaf is the deepest leaf, or this leaf is not a deepest leaf? Like just think, if you are standing at this node, and if you know the height of this node, or the depth, you can say, I'll say a height or depth, doesn't matter. But if you are standing, you know 5 is at the second level, but the maximum level of the tree is 3. So basically you won't add in your sum variable. So basically you want to add the nodes which is at the deepest level. How to do that? If we know the depth of the tree, to do that you can use you can create a function, or you can traverse the tree to find the depth. Let me just show you the code. I will name it at dfs, will pass root, it will return int value which will be the sum. So if first we'll use recursive approach, like if you reach at the last node, or which is null, you will return simply 0. If root double equals to null, return 0. I hope you are understanding why we are doing this. Basically we want to distinguish the leaf nodes. Like we have this leaf node and this leaf node, we want to distinguish which is the deepest. And to do that, like if we are standing here, we should know the depth of this tree and the current depth, or the depth of the node. Basically these are the two things we need, which is the maximum depth or maximum height, you can say, and the current height. If both are same and your node is also leaf, then you will add. For example, here you'll add this 7, you won't add 5. 5 is, even though 5 is leaf, but maximum depth which is 3 and the current depth which is 2 is not equals. For that we are finding depth here, and we'll return basically its parent 1 plus max of. Okay, we will return this. Like if we came here, root is null, it will return 0. It will return 0. Like this 2 you have 0, and its parent it will return 1. and similarly it will return the maximum value from the left and right. You will return 1 plus the value maximum value you have received. You can see 1 plus maximum value from the left and right. You will return 2 and this will be returning once. So this 2 will, like, on the left you are getting 2, the depth your current, let me move this, that your current depth is left depth is 2 and the right depth is 1. So to choosing the maximum from this and adding 1, so it will return 3 to its parent and it will return 4. Simply you know the maximum depth using this code. Just think about the pseudocode rather than you find the maximum depth. Now you want to simply just find if node is if your current node is what we will say leaf. So you can name it anything, doesn't matter. We'll pass the root, we'll pass the current height and max height, max h. Basically we will check if root left, if left let me know. So we'll check if left is equals to null, if root arrow f left is null and root arrow right is equals to null. If your left is null and right is null, what does it mean? That it is a leaf node. It doesn't mean it is the deepest leaf node, but it is a leaf node. So we want to check if it is deepest or not. To deepest, we'll compare the current height with the maximum height. And if your current double equals to max of h, so you will add the value of that node in your sum variable, which can be globally, but I'll prefer you can pass it here, or sum plus equals to root arrow n. And if it wasn't the deepest leaf, so you'll simply just return, or even after adding value you'll return. And like if this is the base case, if this doesn't work, or like if we are here, we want to go left and right, so basically we'll call the function here, we'll pass root arrow left if left exists and current height plus 1, as if we are standing at any node, we want to go left or if we want to go deeper, you will increase it height as you are going in the deeper height level, or you are going below. Like if you are standing at the 0 position, you want to go here, here or here, so you will increase it level as you are going from 0 to 1, and if you are going from 1 to the second level, you will add 1 more. Simply you will do for the right. I don't think we need to see the code. This was more than enough. I'll drop the code in the comments, but I think we got the approach. I think this was the more approachable rather than using that queue, but that is also a good approach. Like if you want to if you think logically, you can also get this approach. I couldn't get the first approach. So thank you for watching. And the time complexity, let me just tell. Time complexity is big O of n. Space complexity is almost big O of 1, as we are not using any extra space. And for the earlier code, space complexity was big O of n, as we were using a queue.